Hi class, welcome to lesson 40, part 2 of classifying chemical reactions. Today we're going to continue looking at how we balance equations using coefficients to make sure that matter is never created or destroyed. But today we'll classify reactions as single replacement or double replacement. Now, we will verify that a chemical reaction will occur using reference tables F and J. So there are 5 major types of chemical reactions. In video A, we talked about synthesis, decomposition, and combustion. So this video will focus solely on single replacement and double replacement. If we take a moment to look at this diagram to the right, we can see that single replacement involves a single element and a compound. And in single replacement, the single element replaces its like element in a compound. So that means in single replacement, a metal can replace a metal, or a nonmetal can replace a nonmetal. Here you can see the generic equations for single replacement. Here is another real-life example of single replacement. Long ago, you might have remembered there was a couple, Brad Pitt and Jennifer Aniston. They were sometimes referred to as Benifer. But then along came Angelina Jolie. Now, Jennifer Aniston is all alone, and Brad Pitt is with Angelina Jolie, or Brangelina. Or maybe they're not together again, but this really was a thing. In this chemical equation, we begin with iron 3 oxide and aluminum, and then we form iron and aluminum oxide. Notice here how the metals iron and aluminum switched places.
Single replacement or single displacement reaction. Here's an example. Our reactants are one element plus one compound, and those form one element plus another compound. Notice that we are just switching the metals to form our new products.
Just because you mix two substances together doesn't mean you always get a chemical reaction. A lot of times in everyday life we mix things together and no reaction occurs. For example, if you drop a nickel coin into water, nothing's going to happen. So Table J can help us find out more about when a single replacement reaction will occur. Table J lists the activity of both metals and nonmetals. Only more active metals can replace less active elements in single replacement reactions. So here we can look at magnesium and sodium. Now sodium is by itself and it wants to replace magnesium, because if sodium replaces magnesium, sodium can become an ion with a stable noble gas electron configuration. Since sodium is more active than magnesium, this chemical reaction can occur. So sodium will kick magnesium out and take magnesium's partner, chloride. Now, elements combine to obtain stable noble gas valence electron configurations, which means in a compound they have a total charge of 0. Right now, this formula is not balanced because on the reactant side, I have 2 sodiums, but on the products, I only have 1. So you can see that on the product side, we need more sodium. To get more sodium, I'll have to add more of this sodium chloride unit. We can do this by adding a coefficient of 2. Now, when we examine both sides of the equation, we can see that we have 1 magnesium on each side, 2 of these black chlorines, and 2 blue sodiums. So this equation is balanced. Let's look at the next reaction involving zinc and sodium chloride. When looking at single replacement reactions, we have to see if the alone element, in this case zinc, is more active than sodium, the bonded element. Now, remember that in a single replacement reaction, you can only compare elements that are in the same column. So, again, we're looking at zinc and sodium. Since zinc is less active than sodium, there'll be no reaction. Because no reaction occurs, there's no need to balance or complete this reaction. Finally, let's look at the reaction between barium and sodium chloride. Looking on table J, you'll notice the lone element, barium, is more active than the bound element, sodium. So barium can replace sodium in a compound. So sodium will be by itself, and barium will bond with sodium's partner, chlorine. Now barium has a +2 charge, and chlorine has a -1 charge, so 2 chlorines are required. The last step is to balance this equation. When predicting the products of a single replacement reaction, the first step is always to make sure the reaction will occur. Check table J, make sure that the lone element is more active than the bound element. Switch partners, use the crisscross method for your new compound, making sure that the total charge is 0, and finally balance. Don't forget, diatomic elements require a subscript of 2 when they're alone. Let's do a couple more practice reactions together. Remember that you always want to look and see if the lone element is more active than the bound element. So here we're going to compare lithium to sodium. Since lithium is more active than sodium, lithium will replace sodium in this reaction. In the next reaction, we must compare magnesium with sodium. Since magnesium, the lone element, is less active than sodium, no reaction will occur. In the next example, our lone element is chlorine. Chlorine is a nonmetal. Chlorine can only be compared to other nonmetals, fluorine, bromine, or iodine. Here, we're going to compare chlorine to bromine. Since chlorine is more active than bromine, chlorine can replace bromine in this reaction. The next reaction involves another set of nonmetals. Here, we have iodine that is alone. We are going to compare iodine to fluorine. Iodine is less active than fluorine, so no reaction will occur. In the final reaction, we want to compare copper to silver. Notice copper is more active than silver, so it can replace silver in a reaction. Since this reaction occurs, you can see in this picture we have a piece of copper wire suspended in some silver nitrate solution. In this reaction, the copper atoms in the wire are changing places with the silver ions in the solution. So you can see the clear silver nitrate solution is becoming blue as it adds the transition metal copper to it. And you can see on the copper wire, this haziness is actually silver atoms coming out of the solution. Use table J to see if you can figure out which of these metals can react with a solution containing zinc ions. Which of these metals is more active than zinc? The other type of reaction we are going to look at today is called the double replacement reaction. In a double replacement reaction, the two positive ions of two different compounds are exchanged. So here, in this example of magnesium oxide and calcium sulfide, you can see that the magnesium and calcium switch places. Double replacement reactions often involve something called a precipitate. A precipitate is a solid product formed when a substance does not dissolve in water. You can find precipitates on reference table F.
A double replacement or double displacement reaction is really similar to this because our reactants are now two compounds and those form two different compounds. Think of it this way. The inner elements combine and the outer elements combine to form our new products. Or you can think of it as the metals are switching again to form our new products.
In this reaction, you can see that when potassium chromate and silver nitrate react, the metals switch places, creating silver chromate and potassium nitrate. Just like in a single replacement reactions, just because you mix two compounds together, you don't always get a reaction. Double replacement reactions only form if a precipitate is made, a gas forms, or water is formed. Otherwise, if the products are all aqueous or soluble in water, then no reaction occurs. You can see in the picture to the left, here are several different precipitates. A precipitate occurs when you mix two aqueous substances and you form a solid that is opaque and will eventually fall to the bottom of your test tube. In our example question here, let's try and find the precipitate. To find a precipitate, we're going to look at reference table F. Reference table F has two portions. The left portion describes ions that are soluble, except when combined with any of the exceptions, while the right portion shows ions that are insoluble and lists the few exceptions that occur. When using reference table F, you only have to find one of the two ions present. So in silver chromate, we have to find either the silver atom or the chromate ion. When I use reference table F, I don't read the exceptions. So when looking through the list, I do not see a mention of silver. But as I continue looking through the list, I do see a mention of chromate. Here, I see that chromate forms insoluble compounds unless with group 1 or ammonium. Silver is not in group 1, so our precipitate is silver chromate. Let's see why potassium nitrate is not a precipitate. So here we're going to look for potassium. I see no direct mention of potassium. So next I'll look for nitrate. Here I see that all nitrates are soluble. There are no exceptions. So potassium nitrate is soluble. It is not a precipitate. When carrying out double replacement reactions, we switch metals very much like foiling in algebra, where the outside ions come together and the inside ions come together. In this example, we have silver nitrate reacting with potassium chloride. It is easiest to write the products in the form of a word equation. So the silver and potassium will switch places, forming silver chloride and potassium nitrate. Before we go and write out this equation, we should figure out if it actually occurs, seeing if a precipitate is formed. So we'll look for ions of either silver or chloride. There is no mention of silver ions in either part of reference table F. There is, however, mention of a chloride ion. Chlorides are under halides. Chlorides are soluble unless with silver. So silver chloride is an insoluble precipitate. When something is soluble, it will have the symbol aqueous. When something is insoluble, it'll have a solid symbol. So silver chloride is insoluble, so it is solid. Potassium nitrate we can find on reference table F. So there's no direct mention of potassium, though potassium is in group 1. Let's look at nitrate. Nitrates are always soluble, no exceptions. So potassium nitrate will always have an aqueous symbol after it. Now it is your turn to try and use reference table F and find which of these compounds are soluble in water. Remember, when something is soluble, it will have an aqueous symbol, and when something is insoluble, it will have a solid symbol. As a recap, when predicting the products of a double replacement reactions, you should identify the ions, switch partners, check table F. If all of the products are soluble or aqueous, then there will be no reaction. Crisscross and balance. Now that we've identified the 5 major types of chemical reactions, see if you can classify these reactions below. This concludes Lesson 40. Make sure that you've taken good notes. You bring your notes to class and you complete your Google Classroom homework. See you in class.